baby. Let's do some science experiments. Anybody out there want to do some science? Let's do, yeah, we gotta add a little universal indicator over here on this flask over here on the left. The flask on the right already has some added. If you look closely, you can see that yellow color that tells us our pH. It looks like about 6, yeah? Let's add some universal indicator to this flask over here on the left. Right here you can see that the universal indicator is a green color. Let's add it to our, this is my water from my tap. You can see that tap water is nice and neutral. What's up, Global? What's the problem? Huh? Add calcium ions. How you doing there? Very cool. I guess I could add some calcium ions. I might have some calcium chloride I could add. All right. Got our universal indicator added. Let's start adding acid or base. Let me get a little bit of light here on the... There we go. So you can see these colors over here showing the different pH values and whether it's acidic or basic. Let's add a drop of hydrochloric acid over here on the left. Like, I don't know, 2 drops. 1, 2. How you doing there, Simon? See that nice red color where the acid is staying in the center of the vortex. And then as it gets pushed down onto that stir bar, it spreads out. Looks like we're at like pH 6. I'm going to keep adding acid. There's 2 more drops. And you'll notice as I add acid, the pH should drop. Yeah, it's like maybe a pH 5. I'm going to keep adding. Let's go 2 more drops. 2 more. There we go. Oh, I don't have any sulfuric with me. I do have some other experiments ready for you today, by the way. Looks like we're down to like pH 4. Let's go 2 more drops. Actually, 3. Get that baby down to, there we go, a nice red pH 3. Now we can try to start adding some sodium hydroxide base, 20% by weight. We're going to add that over here to the flask on the left. On the flask on the left, the stir bar that I've added is a little larger. Look at that rainbow, baby. Come on now. That's a good one. That is a beautiful one. Yeah, I could add calcium hydroxide. The issue with calcium hydroxide is not very soluble. And so that's gonna cause everything to kind of look cloudy. All right. Cool, Alex. Great to hear that. Great to hear that. Okay, let's check this one out over here. So Simon had to get a new iPhone to replace the old one because the old one would not let them make calls or text anymore. Interesting. Over here on this side, I have a smaller stir bar. Hello there, Eliana. Glad to hear it, Green Bean. I'm going to start adding... Michael, I wouldn't want to drink this because one of the indicator dyes used to be the main ingredient in X-Lax. So, you know, that might end alive in a couple minutes if we tried that. Notice over here, I'm doing the same thing. The only difference is on this flask over here is that the stir bar is much smaller. See, there's a much larger stir bar over here, and this one over here is much smaller. But I'm just adding... hello there, Michael. I'm just going to add some more hydrochloric acid. The acid I'm adding is the same acid that's found in your stomach. It's just this stuff is a lot more concentrated. What's wrong there, Nicholas? Okay. Green Bean, I'm in the... Excuse me. Sorry, folks. I'm in the United States. Here we go. I'm going to start adding some sodium hydroxide base. Oh, no, Richie. We just got started. So as I add base, the pH should increase. But remember, the stir bar here is stirring quite slowly. Here we go. I'm going to add 2 drops of sodium hydroxide base. You can see the violet color grow in. And then when that stuff hits the bottom, it's interesting, right? It seems to make the bottom... What's interesting now is the bottom's like pH 10. The top is pH 3. And because pH works by powers of 10... That's actually a difference in 10 million in the acidity between the top and the bottom. Because 3, 10, Let's see, 10, then 100, then 1,000, then 10,000, then 100,000, then a million, then 10 million. So that's well, it's not anymore because, the solutions are reacting. But that was a difference when we saw that red and that violet at the same time. That's a difference in acidity of 10 million times. It's pretty remarkable. All right, let's keep adding some base. A couple drops here. I'm going to turn up the stir speed down here. You can see me doing it. Get that stirring going a little greater. Look at that beautiful violet color. Looks like the Minnesota Vikings colors. I don't know if you got any NFL fans out there, but that kind of looks like the Vikings colors. Let's switch over here. We're going to do it on the faster speed. Here we go. I'm going to add 2 drops of the hydrochloric acid. Same acid that's found in your stomach. Just remember, this stuff is a lot more concentrated. Hey, we got someone born in Minnesota, a Vikings fan. We got someone in North Carolina but living in Georgia. We got VK doing some chemistry studying. All right, let's go 2 more drops of acid. Notice as I add acid, the pH drops. That's all right, Richies. Pretty cool. All right, notice we've got pH 3 here. I'm now going to start adding some sodium hydroxide to this side. All right, and as I add the sodium hydroxide, you should see an increase in pH. We got some from the Vatican, some from Connecticut. All right, let's go 2 drops of sodium hydroxide. In they go. Let's see what happens. Flash of the rainbow. We got that rainbow working just great today. That is gorgeous. Man, I want to see that again. Someone from Germany. Inquisitor. We are talking 100% degree of dissociation. We're using strong acids and strong bases here. Hey, we got someone from Syria. We got folks from all over the globe. I'm loving it. Eliana, you really don't want to drink it. What's your element in period 3? Yours is argon. Let's see. We got potassium, calcium, scandium, titanium, vanadium, chromium, manganese. No, that's the 4th. Sorry. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon in that 3rd period. Yep, you're right. Very cool. I got the. Oh, look at that rainbow. Come on, let's get her again. Let's get her again. Favorite element, let's see, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Sodium, magnesium, probably sodium. Maybe magnesium. I think magnesium because that's found in chlorophyll. Magnesium ions found in chlorophyll. If it's in the chlorophyll structure, chlorophyll's green. Chlorophyll's the stuff that gives plants their green color. If the magnesium ion is present in the chlorophyll molecule, it has a green color, and if it pops out, it takes on a brown color. Someone here from India watching at 2 a.m. All right, Derry, here's rainbow for you. Let's go. That's right, Maples. I'm adding hydrochloric acid. Haha, fat oxygen. I love it, VK. Hello there, Raven. Okay, here we go. Let's add a couple. 1, 2. So very cools. I maybe should try doing, but I have my own element song that I sing. Very cools. What I've done is I've changed the words to Johnny Cash's I've Been Everywhere, Man. And instead of singing the names of cities, I sing the names of elements. The indicator, Maples, I'm using is universal indicator. All right, let's add some hydrochloric acid. Thank you there, Derry. A couple drops there. We got another one, Al Dursi from India. Sonk wants something to drink. You really don't, Sonk. Here we go. I'm going to add a couple drops of base and see if we get that rainbow going. 2 drops. Let's do it. Sorry there, Ari. I don't understand that language. I'm really sorry. I only understand English. And we got the rainbow. Yeah, edits. I'm using universal indicator. The first 54... T. George wants to hear the song. I always screw it up. I usually screw it up. I have to practice a couple times, but I can say the elements in order from memory. Thank you there, Samo. Thank you there, Hasisul. I apologize. I know I'm not saying your name right. Thank you there, Tyrone. All right, man. That's Tyrone. Let's see if we can do it here. Let's add a couple drops of universal indicator, and they go. Excuse me, base. That's base. DK likes Drake. There's your rainbow for you. We got the acid-base rainbow. We have really got it going well today. We got someone from the United Kingdom here. I love it. Thank you there, Ivan. If you can say the first 100 digits of pi, you'll donate 100. I can't do it, Sonk. Let's see if this is what I can do. 3.14159, 3.1415926535589. That's as far as I go. That's as far as I go, man. Thank you there, Alpha. A couple more drops here. We're adding some acid. Thank you there, Serena. That's cool. Very, very cool. Since say the first 100 digits of pi. I love it. I'll get you the periodic table of elements. I can usually do that. All 118 of them. Aiden, I have done that. We occasionally will do experiments where I bubble. You know, I just exhale my breath. Here we go. Add a couple more drops. Oh, nice. We got nobody going to university for a physics degree. I'm loving it. I have no idea, Tafa. I have no idea. Here we go. A couple drops of acid. So, Hatim, what I'm using is 20% by weight hydrochloric acid. That's what I just added. I'll add some up here at the top to make it acidic. And now I'm going to add 20% by weight sodium hydroxide. Here we go. A couple drops. 1, 2, 3 of the base. Let's see if we get that rainbow going. I think I added too much base that time. It's overwhelming. I got a little rainbow flash. Thank you there, Ivan. I hope to hear you in the comments of those. Thank you there, Midwest. Let's add a little more acid here so we can get the pH back down. I'm adding hydrochloric acid right now. Guess the element by its atomic number, 84. Mercury is 80. Mercury, 84. Man, that sounds like radon. Radon's 86. I think that's polonium. You got it there, Ryan. Thank you there, Hatim. Appreciate it. Thank you there, Kamui. All right, here we go. 2 drops, baby. 2 drops. Thank you there. There we go. We got a little rainbow flash. Come on now. Let's get a little more drop in there. Let's see if we can get it. Yeah, I love it. I love it. Thank you there, Umbrella. Appreciate that. The pH, Aiden, of the sulfuric acid that I'm adding is like -1. And that of the sodium hydroxide I'm adding is like, I don't know, 14 or so. It's up there. Tafa, see you later, man. When I catch it, I don't put up with racism. See you later, bud. I'll ban you right away. Hey there, Tanisk. What material creates coal and water when heated? Interesting. Thank you there, BU. Gallium is your 3rd favorite element. Beamer Boy, I'm testing universal indicator. I did, nobody. I'm not going to repeat it, I'm not going to repeat it. It's clear as day, though, when people are doing it. I see it a lot. They try to get me to say something that sounds like a racial slur. That's all. That's what they're doing. So Viper's favorite element is bromine. Tanishk. Thank you. Hey, you guys want to see a different? Want to see a different experiment? You want to see the color layer separation? Yeah, I got a PhD in chemistry. Nobody. I have a master's degree in chemistry as well. So BU wants to make it neutral, so I'm going to start adding some base to do that. Here we go. I'm going to add some base up here at the top. All right, folks. There you go. There's your neutral. Thank you there, Ivan. I appreciate it. All right, folks want to do I almost got you your pH 9 right there. Very cools. Pretty close. We'll add another drop so we can get there for you. All right, let's do the color separation experiment. Administrator, do I think it's worth it to get a PhD in chemistry? It depends what you mean by worth it. Some people get PhDs in chemistry because they want to make a lot of money. I did it because it's what I wanted to do with my life. So, different strokes for different folks, huh? Absolutely, Roy. I use a ton of math. Which theory best explains the chemical bonding and molecular shapes? Probably molecular orbital theory. If the pH scale goes from 1 to 14, how does an acid go negative? So, Ryan, the pH scale actually goes further than 1 to 14. It's based on the mathematical definition, which I'm just not going to go into here, but, based on the mathematical equation for pH, you can indeed get negative pH values. If folks want to know that, I can talk about it. But anyway, here we go. I got this bottle here, okay? Here we go. We're going to add some purple food dye to this bottle, okay? Pretty much, Ali. Here we go. Let's add a little bit of purple food dye to this bottle. It's got a colorless liquid in it. Does the third transition series start? I missed it at lutetium. Oh, look at that. Isn't that gorgeous? Let's put another drop in there. I mean, just watching dye go into some fluid is kind of pretty. Hey, thank you there, V. Thank you there, VK, explaining the pH for me. Oh, thanks there, Potato. Hello there, Semi. Thank you there, Alan. What's the best way to study chemistry? Well, I think it's, hey, thanks there, Obtorge. I don't know. For me, it was just drilling. I just did a lot of problems. That's the way I did. Okay, here we go. Here we go. I'm mixing up the colors, okay? And now, thanks there, Adelaide. I appreciate that. Now we're going to add some salt to this, okay? So I got my it's a clear fluid because you can see through it. It's a clear fluid. And now I'm going to add some salt to it. Does the liquid have a scent? It does a little bit, Semi. Inquisitor, I guess we're kind of doing organic chemistry right now. Here we go. Now I'm going to add salt to this bottle of fluid. You can see it right here. All right, that's a bunch of table salt, sodium chloride. All right, here we go. And in goes the salt. Look at it just sprinkling down like snow. All right. That looks nice. And I think I'm just going to, just for the heck of it, no, I'll leave it like this. Okay, let me shake this thing up. See if we can get some of that salt to dissolve. Umbrella asks, is it just water? I don't know, let's make some observations and see if we can figure it out. It does look like a murky purple. All right, I got to keep shaking to make sure it gets dissolved. Does the salt have any caking agent in there? No, it's fairly, it is not potassium permanganate, and the salt does not have a caking agent. It does look a little bit carbonated, I agree. It's not going to make crystal. I'm not doing experiments with bromine in my basement. Edits. I have a video about thermite. You can check out my shorts. You can look through those. It's one of my most popular. So if you just sort by popular, it'll be like in the top, 10 or 20. Yes, I do have some bromine. Very cool. Is it going to explode? I don't know. All right, here we go. I hope I got it dissolved. Let's find out. I might have to add a little bit more salt, but let's see. Oh, it's working, baby. It's working. It's working, folks. Come on now. Come on, baby. Look at that. You see it? Isn't that gorgeous? It's separating into 3 layers. And wait a minute, as time goes on, it seems like the 3 layers are going to 2. And what's interesting is we started with a purple dye, And now there's a blue one on the bottom and a red one on the top. What gives? What's going on here, huh? Let's shake it up and try it again, shall we? Here, let's just shake it up, see if it remixes. Sure enough, it's purple again. And then we're going to go ahead and just see if it separates again. I don't know. Let's watch. I agree, AJ. What is this liquid? Well, we'll talk about it. And you can go through my shorts. You know, I think I published this one maybe, I don't know, about a year ago, maybe a little less than that. Isn't that cool? Isn't that just beautiful? So here's what's going on. I think you all know that I didn't just put water in here. I put water and acetone. Thank you there, Pumpkin. I appreciate that. I'm guessing it's pumpkin. All right. So here, let me show you this. So we'll move this one over to the side so we can see both. Here, let's get this out of here because we're not doing that experiment right now. We're doing a different one. So in this bottle, what I did is I mixed 210. This is a half-liter bottle. Okay, this holds 500 milliliters. And what I did is I added 210 milliliters of water, and then I filled it the rest of the way with acetone. So acetone, that they use that in like nail polish remover. It's an organic fluid, all right? And water and acetone, they mix very well. So this is like a singular fluid, but it's not just water. It's a mixture of water and acetone, all right? Now, when I add dye to this, because the fluid is perfectly mixed, it's just a singular fluid. Here we go. We're going to add 2 drops of purple food dye. In they go. 1 drop, 2 drop, and of course that looks beautiful in its own right. But the purple dye, even though it looks like it's made just of a singular purple dye, it's actually made of a red dye and a blue dye. And of course, we know that, right? Red and blue together give you purple. Okay. Now, what I do is I add salt to this mixture of water, acetone, and purple food dye, okay? Let's watch it. Here we go. Where's my funnel? Come on, Kutzelman people are watching. Here we go. Where is it? Where is it? Where is my funnel? Ah! I lost my funnel. Oh, no. Ah, here it is. Okay, sorry about that, folks. Here we go. I got too much junk hanging around here. Okay, in goes the salt now. In goes the salt. And it goes. And what happens when I add the salt is the salt and the water are extremely attracted to one another. So just imagine, 2 people, when they find each other, and, this happens to a lot of people. 2 people meet, and they love each other so much that they begin to see each other exclusively. And that's what's kind of going on here with the water and the salt. The salt and the water are so strongly attracted to one another that they only attract each other and they exclude all others. In other words, you could think of it as they start dating each other exclusively. So the salt and the water combine and attract, and they push all other fluid out, which in this case is just the acetone, right? So the salt and the water, they combine, and the acetone, that gets pushed out. And what's interesting about this is, boy, that one mixed pretty quick. I think I need to get just a little bit more salt in here. So let me just shake this up just a bit. And the other thing that you'll notice is the blue dye ends up dissolving in the water, the salt water layer better, and the red or pink dye ends up dissolving in the acetone layer better, and that's why you get the color separation that you see. So down here, this is salt water. Remember, these two are kind of, so to speak, they're dating exclusively. We're making, an analogy here. And then on top, this is the acetone layer that has gotten pushed out. Now in the middle, there's a mixture of both types of fluids. We call this an emulsion. That's a transient mixture of salt water and acetone. And both dyes are in here, which is why it looks purple. The blue dye goes better in the water layer, and the pink dye goes better in the acetone layer. Isn't that cool? Then oxidize it. It's not ethanoic acid. It's, what do they call it? Ethanone. Excuse me. It would be propanone. That's the proper name for acetone. What would happen if I added a surfactant? Do I have one down here? Do I have detergent down here? What a great idea. I am so sorry. I do not see. I am sorry. I don't have any detergent in the basement with me. I apologize. That's what. Yeah, a lot of people say that, Pumpkin. A lot of people notice that. That's exactly what it looks like. It looks like the flag. Yep. Let me shake it up and you see it again. Here we go. In 5 million years, I'm gonna be Tommy Ruthenium. That's prime comment right there. Oh, HR Nightmare. Can I make it the Belgian colors? Probably not. That's going to be tough. Where does the third color go as it settles? So there's really only two colors. The red and the blue are mixed in this middle layer. And this middle layer, let me shake it up again. This middle layer is made of salt water on the bottom and acetone on the top. The blue dye goes into the salt water. The red dye goes into the acetone. This middle layer is a mixture of the two. It's a mixture of the acetone and the salt water. It's just like, salad dressing, water and oil. When you mix, there's that middle stuff that, that persists for a while, and then the two take a little bit to separate. This has both dyes in it. Thank you there, Sink. I appreciate that. Hey, let's go back doing the acid-base experiments. What do you say? What do you say? Are you done with doing this? Because these are the only two bottles I had prepped for you. This takes a while to prep, so it's not like, unless you want me to just shake it up again. We can keep shaking this up and talking about it, but we can go back to the acid-base experiments. So like Potato says no. The Very Cool says, looks like we got some no and yes. Very Cool wants some other experiments. Gorshu says this is dope. What do you call it when the salt combines with the water? Dissolving. Hello there, 67 editor. One more shake, says OB. There you go. Add yellow to it? Sure, why not? Let me get a little bit of yellow dye. We can add a little yellow dye and see what happens. I don't know. Let's see what happens. We're going to add another dye. Give me a second here. Oh, where's my yellow dye? Do I have any? You know what? I don't have yellow dye, but I have a greenish yellow dye that I can add. All right, let's just add some of this, see what happens. Why not? I don't know what's going to happen. Okay. Place this in a glass on a hot plate. All right, here we go. What's the dye? The dye that's in here is just neon purple food dye. All right, I used the purple kind. That's what I used. Haha, it's funny. Okay, here we go. I don't know what's going to happen. All right, let's do it. Here goes the green dye. And it goes, boop. I love the way that looks when it goes in there. Right now, it looks like the green dye likes the acetone layer. But look at that. You can see that the green dye is maybe a little bit more dense than that alcohol layer, but less dense than the salt layer, which is why it's resting there. And I can also see, can you see there's like some yellow here? I think that there's a yellow dye in our neon green that's going to like, so to speak, the salt water better. So I imagine that yellow is going to go in here and make it look kind of greenish. Let's find out, though. We'll just shake it up. I'm guessing there's two different dyes in here. I'm guessing there's like a blue dye, maybe, and a yellow dye. I don't know. Let's find out. Let's shake this up, see what happens. Give her a shake. Oh, man, it looks kind of orange-brown now. Let's see how this clarifies. There we go. Let's see what happens. Oh, yeah, we got a little greenish on the bottom now. That prediction was correct. And up there at the top, look at it. Still that nice red-violet. Isn't that cool? Very cool. Come on, man. We got like green and red now. I love it. Yeah, insert. I mean, this experiment's pretty safe to do at home. You can, again, you can look at my shorts, my YouTube shorts, and they explain exactly how to do this particular experiment on YouTube shorts. What's in the bottles, double OG, what I do is I add about 210 milliliters of water, and then I fill the rest. This is a half-liter bottle. I fill the rest with some acetone, and then I add 50 grams of salt. And then you just, you play around with different dyes like we have here. That's the first time, though, I've made this color separation. So thank you for the suggestion to add another color. Let's add another one, huh? Let's add another one of this guy over here. Here, what do you want to do? We could add the pink. We could add the blue. Well, the blue's probably going to end up here, I imagine. We've already added the green. Of course, I've added the purple. Let's see what other colors I have. Hold on a sec. I'll give you some more options. Give me a second over here. I can find a few more. Yeah, I think I just got neon blue and like this neon magenta. Ah, these are your options. Let's just put them right there. We already got that one. We already added this one over here. I don't know. What do you... I guess it's... What do you want to add? Do I have any black? I do not. Neon blue, I'm seeing. Try magenta. Grab some paper, draw an element, square in the periodic table. Somebody wants white, somebody wants purple, someone wants magenta. A lot of people are saying red. I'm seeing a lot of red and magenta, so that's what we're going to do. Okay, that's what folks wanted. We're going to add this stuff right here, all right? We're going to add it right here. I'm imagining it's going to go up here. It's just going to add like the other stuff, but I don't know. That's why we do this stuff. I have no idea. I'm just going to guess that this is going to get more red, but who knows? Who really knows? In goes a drop. And what's nice is we have our control over here because these were pretty much the same shade of red. So if this gets darker, then we know it's the same dye, probably. If this layer gets darker, it's probably the same dye. Yeah, Clippy, we got some density going on. Although that does look like it's a little more yellow to me, doesn't it? I'll bet that top's going to turn orange. Let's see. I don't know. Here we go. Give it a shot. Now this one, the last one looked orange when I did this. This one kind of looks like a, I don't know, like a magenta. Let's find out. See what's going to happen. Give her a go. Oh, it looks like some of the red went down to the bottom, right? Because this used to be blue down here. And now it's like, man, I don't know. I think it is more red up top. What do y'all think? Let's get these close together. Maybe I'm just seeing things. No, I think that shade changed. But that, remember, this used to be like a blue color. So some of the red definitely dissolved down here. I think. I'm going to add a little bit of blue to this side over here. Let's add a little bit of the blue, see if we can get this a little more purple. Again, I'm guessing the blue color will go down in there. The solvent DK, the solvent is water, salt water, and acetone. Here we go. Oh, look at that. Oh, look at that contrast. Man, is that beautiful. Whoa, that was pretty. So, Haley, what the experiment is I take, this is a half-liter bottle. They're icy bottles, if you know what the drink icy is. I take one of those bottles, I add 210 milliliters of water, and then I fill the rest about to here with acetone, and then I add, I mix it up, and then you add a dye. It can be a bunch of different dyes. And after you add the dye and you shake it up, it looks like a singular fluid. But then what you do is you add 50 grams of salt, give it a shake, and then the layers separate. Look at that. We're back to the original colors, man. Come on, man. Oh, that's pretty. Oh, that's really pretty. My favorite lanthanide is probably niobium, I'm guessing. Thank you there, Richie. I don't have any, I don't have any white dye. I don't have any. What causes the color to choose which liquid to go to? That's a great question. So water is, I'm going to get a little chemistry here, folks. Water does a special type of interaction with other molecules called hydrogen bonding. Hydrogen bonding is, if you're familiar with DNA, hydrogen bonding is what makes the base pairs in DNA stick together. In other words, you might know that DNA is a double helix. It's got two strands that hook together. It's actually hydrogen bonding that makes those two strands connect. And water is really good at hydrogen bonding. And so any dye that's good at hydrogen bonding tends to go in the water layer. Any dye that's not good at hydrogen bonding tends to go in the alcohol layer. It's more complicated than that, but that gives you a basic idea. Hello there, Rachel. Hello there, Walker. Let's add a drop of blue to this one just to finish off, and then we can go back to the acid-base experiments. Both. Both I love, BZ. All right, here we go. No, more pink, says E. Really? Really? Pink. All right, folks, you want more pink? We're going more pink. I saw 2 people say pink, so that's what we're going with. Here we go. More pink. Here we go. More pink. Boom. And Wildberry, this one's for you. This one's for Wildberry. I saw you, Wildberry. Come on, Wildberry Bleach. Here we go. A little blue. Come on. Look at that contrast. That's so gorgeous. That is really cool. All right, let's give it a shake. What are we going to see? I'm guessing we're going to see, I don't know. I think it's going to look like this, but I don't know. Here we go. Oh, man, that looks terrible. It looks like a brownish orange green. Here we go. I'll put that over. Oh, look at that bottom. It's got a nice green color to it. Very cool. Why doesn't the dye hydrogen bond with water when it gets to the bottom of the acetone? So some of the dye here, it just preferentially likes the acetone layer, so to speak, because the dye doesn't hydrogen bond well with water. It's going to go into the more organic layer a little bit better. That's a really dark green there. So determining which layer a dye is going to go into is, it involves something that in chemistry we call intermolecular forces. And those can be particularly pernicious to figure out what's going on. The only 3 color I can do is by doing this and then watching the 3 colors that occur during a separation. Cool bottle, folks. Thanks for the suggestion on what I should do in that experiment. That was a lot of fun. That really was a lot of fun. I'm going to pop the acid-base reaction on there so we can kind of watch this separation. We do some acid-base experiments at the same time. I'm not drinking it. No way. That would cause me a very bad evening. All right, let's back her up. If I leave it out lying long enough, will the colors separate? Indeed they will. Indeed they will. Mix both together. Oh, I apologize. I'm not going to do that. So I'm adding some acid over here to the flask on the left. And you'll notice that the color is going to shift to a red color. That's because the indicator dye that I have in this flask on the left tells you the pH. And when I add acid, the pH will drop. We're heading down to pH 3. So long there, Richard. Thanks for hanging out. All right, let's add a little more. One more drop. All right. Thank you there. What if I happen if I added oobleck to it? Okay. All right, let's see if we get the rainbow, baby. I'm going to add now some sodium hydroxide, which will raise the pH. But what's interesting is, it doesn't immediately change the pH to 10. What will basically happen, it will be a lot of regions in the flask. It'll be at a bunch of different pHs at the same time. Let's see this here. Let's go like 2 drops. Come on, baby. Give me the rainbow. There it is. We got a little flash of it. There it is. Oh, that was beautiful. You can see that vortex purple, all those colors. Come on, baby. Let's add a little drop of the base there. I'm going to put a little red there at the top. And then that rainbow. Beautiful. Thank you there, Walker. Thank you there, Eloise. Appreciate it. Let's add a little more acid, get the pH back down. All right, then I'm going to add some base. And it's going to go up to, pH 10 or whatever. Here we go. Let's give a little drop. A couple drops here. 2 drops to see if we get that rainbow going. There it is. Oh, I love it. Let's get another drop there. Come on now. Oh, I added too much. No, I didn't. That worked okay. A couple drops here. Get that. Oh, look at that gorgeous color. It does, Eloise. It doesn't, Jason. It doesn't heat up a whole lot. How's it change color, Soda Pop? So there are 4 different dyes in here, Soda Pop. And those 4 different dyes, they all change color depending upon whether they are in acid or base. I can talk about one of those molecules in particular. One of those molecules in particular is called phenolphthalein. Let's add 2 drops here. And phenolphthalein is colorless when it's in acid, and it's pink when it's in base. And when there's acid present, there's a lot of what we chemists call H plus ions around. All right, a lot of this. And the dye molecule, that's phenolphthalein, when there's a lot of H plus ions around, it comes in and it grabs onto it like this, and it makes a ring shape in its structure. And when it has this structure, it's colorless. Now, when there's a lot of base around, this gets stolen. The base steals this. And when this gets stolen from the molecule, pop, the phenolphthalein molecule goes boop, it pops open like that. And with that change in structure, it goes from colorless to pink. So, you know, the structure of a chemical, of a molecule, determines its color. And so just by changing the amount of protons around, the protons are these H plus ions, you can change the color of things. So there you go. And I apologize if you didn't understand any of that, but I hope some of you did. I hope some of you did. You know, it's kind of hard to do this with a million questions coming through, and, you know, I don't have a chalkboard or anything. But you know, folks, we definitely got to respect the chemistry. So let's get back to it. Okay, let's do it here. Let's add a few drops of my phenolphthalein. Yeah, it'll be recorded, Art and Craft. Yep, it'll be recorded. Thank you there, Kimber. All right, let's add a little bit of, you saw it there, Jojo. Make both drops at the same time. We'll do that here in a second. Let me do 2 drops here so we can get that rainbow going. I could do that, Honor. H plus, so soda pop. H plus comes from the hydrogen atom. If the hydrogen atom loses an electron, it becomes that H plus ion. I hear you, Beck. I hear you. That's right there. Yeah, Heisenberg. I think Heisenberg shows up in my basement every once in a while. What can I say? We need to make the color blue. What do you think? I think so. Let's go for it. Here we go, folks. Let's see if we can make this blue, huh? My favorite element, Jessica, is hydrogen. You all let me know what yours is. Thanks, Beck. So yeah, it's getting near where I'm going to be. I've been doing this a while. I can only handle so long because I'm an old man. I can't stream for hours like, you know, my kids do. Those guys will be on there like 4 hours or something like that. We got some folks who liking some phosphorus. So yeah, anyway, I'm gonna be ending the live here soon. What I do at the end of the live is I just flip the camera around and we talk to you. Sing your element song to the first 54 elements at the end of the live. Make it neutral. Let's try it. Make it neutral. I think it's there. I had it there. Thank you there, Juliet. A couple drops there. Thank you there, Russia. Danny, it's just a stir bar, so you can see there it's like a magnetic stir. You can buy one of these. It's a, we call them magnetic stir plates. There's like a fan in here with magnetic blades, and it spins, and then there's a little stir bar in there that's also magnetic. As the fan blades spin, the stir bar spins. Could be there, Beck. All right. I forgot what I was doing. Oh, I was trying to make blue. There we go. There's your baby blue. There's your baby blue. What's the water bottle for? That was for some separation experiments that we did earlier. I love it, Chris. If Iron Man and Silver Surfer teamed up, would they be alloys together? I love it. All right, let me flip this around, talk to y'all for a little bit. We'll read some comments here, see how y'all doing this evening. Is it single or double replacement? Keyhole, I apologize. I got a PhD in chemistry, and I don't worry about the names of reactions like that. So I can't tell you which it is. So, thank you there, channel. Probably not very cool. People don't want to hear me sing. Thank you there, Jessica. I think so too. I'm doing good, Royce. How about you? I don't know if I'm Heisenberg. I am a chemist, Rama. Yep, I'm a chemist. Thank you there, Fly Boy. Come on, Fly Boy. I love it. Can I do the tornado in a water bottle thing? Thank you there, AJ. This has been fun, man. Maybe in a second. You know, I do have very cool. If you go through my long form videos, you can actually find a. You can find. I sang it. It's one of my videos. One of my long form videos. So long there, Russia. Thanks for hanging out. Hey, Chris. Chris and Jessica have a baby on the way. That's awesome. Do you know if it's a girl or boy? Hello, Nathaniel. So, Radish, I specialized in physical chemistry. Particularly, I looked at the physical chemistry of an enzyme in plants that catalyzes the oxidation of water in photosynthesis. Gender reveal party on the 12th. Hey, you gotta let me know. We can do a little gender reveal with our acid base indicator here, huh? Thank you there, Radish. My favorite radioactive element. What a great question, huh? What's our favorite? Technetium, baby. Of course it's technetium. All right, catch you on the next live there, Uptorge. Do with glow in the dark dye. I do have. I've done some lives with like glow sticks. Favorite lanthanide is going to be niobium. We're in the evening here. All right, Jaden. Hey, folks, been great hanging out with you. I had a great time today, folks. We had a really good time, did some experiments. Check it out, man. We did some of the coolest stuff today. Let me just give this one more shake. Let's see if we can do one more rainbow before I call it quits for the day. Let's get this going. We're going to see if we can do it. We can see that color separation. I'm going to try to get this over here to be slightly acidic. Then we're going to add a couple drops of base. See if we can get one more rainbow for the day. Then we're going to call it quits. Thanks for hanging out with me today, checking out some of the beauty of science, enjoying some of the artistic side of science. Come on, baby. Look at that rainbow. We had a great time. I love talking to y'all. Thanks for hanging out with my channel. Consider subscribing. Consider sharing with some folks. It's fun to grow on YouTube with all you helping me out. So thanks for, if you want, give me a follow or a subscription or whatever. Good hanging out with you, and we're going to see you next week. Thanks for hanging out, folks. See you next time.